This video is for section 4.4 part 1, and we're talking about the trigonometric functions of any angle. So we're going to start by using the definitions of our trig functions to determine the values at any angle. Now, the difference today versus our previous videos is that we're no longer on a unit circle. We're going to sometimes be off the unit circle, and we're going to see how that changes our answer. So let's look at this first example. We're given a point P, -3, -5, and it's the terminal side of theta, and we want to find the values of the 6 trig functions. Now, if you remember from the past, from our previous videos, that the sine of theta is equal to the y value of the point. The cosine is equal to the x value. Tangent is y over x, and then from there we get all the reciprocals. Now, if you remember, we said in class those only work if we're on a unit circle. So let's take a look at the point -3, -5. If I plot that point, it's somewhere down here in quadrant 3. And if you think about it, the question is that point, is the radius here for the point -3, -5, does it equal 1? And I hope that you're realizing that in fact it doesn't equal 1. Our radius is bigger than 1 now, because -3, -5 is much larger than 1 unit. Now theta would be this entire angle here. This is what we're trying to find the exact values for. We're going to use what we call the reference angle to help us in a picture. Now we're going to talk more about the reference angle later in this section, but the reference angle is the positive acute angle, meaning less than 90, formed by the terminal side of theta and the x-axis. And really all that means is that I can take my terminal side and I can bring an altitude to the x-axis, and then I have a triangle there. And what the reference angle tells us is that we can now use this triangle to help us. If I go through and label my points, the x value is -3, the y value is -5, and now we can use the Pythagorean theorem to find our hypotenuse. So let's go ahead and do that. We are going to have -3 squared plus -5 squared equals our hypotenuse squared. So 9 plus 25 is our hypotenuse squared. So we get 34 there for our hypotenuse squared, which means that our hypotenuse is the square root of 34. So the nice thing now is that I have a nice picture I can use, and now I just have to use SOHCAHTOA to find all of my trig values. So let's start with sine. The sine of theta is going to be the opposite side over the hypotenuse. So it looks like we've got -5 over the square root of 34. Don't forget to rationalize your denominator. So -5 root 34 over 34 would be for sine of theta. Continuing on with the same idea, the cosine of theta is going to be the adjacent side, -3 over the hypotenuse, the square root of 34. And once again, we'll rationalize. Now for tangent, tangent is the opposite over the adjacent side. So we get -5 over -3. And it's important here that we simplify a negative divided by a negative and turn this into a positive. Now that I have those three from the unit circle and from using SOHCAHTOA, we can find our 3 reciprocal functions just by taking the reciprocals of those answers. So we'll start with cosecant. We're going to flip over sine, and I'm going to flip over the unrationalized version so I don't have to re-rationalize. And I'm going to keep the negative, though, with the top. We just like to write the negatives with the top in fractions or out in front. For secant, I'm going to do the same thing. I'm going to flip over cosine's unrationalized version, and I get negative root 34 over 3. And finally, for cotangent, we're going to flip over 5/3, and we get 3/5. And so you can see here, by using this reference angle in the Pythagorean theorem, we're able to find all the missing sides of our triangle, and now we can find all of the trig functions. And this is really important because we're not on the unit circle anymore. So we can't just take the x value, the y value, or the y over x. But let's take a second and let's look at what we got here and what we came up with. Now, when we look at our answers, one thing I notice is that for sine of theta, we had negative 5 over the square root of 34. Notice it was still the y value, only this time it was the y value divided by the radius. So we still had our y value, only this time on the bottom we also had the radius involved there. So the sine was the y divided by the radius. Cosine, it looks like, was the x value divided by the radius. And tangent really didn't change at all. It was still just y over x. When we look at our reciprocals, we'll notice that for the reciprocals, that cosecant was the radius divided by the y value. And notice that's just the reciprocal of sine there. Secant was the radius divided by the x value, and cotangent was still the x over y. Now, if we bring that back to our original definitions, in these original definitions where sine was y and cosine was x, we were on a unit circle where the radius was 1. So it was like saying divided by 1. This time, we're just going to make it more general and say sine is now the y value divided by whatever the radius of your circle is. Same with cosine, and notice tangent didn't change. So cosecant is just going to be the radius over the y value, secant the radius over the x value, and cotangent still doesn't change. We haven't changed our definitions, we've just expanded them now to be for any point, not necessarily for a point on a unit circle, where r is the radius. Now let's talk for a minute about how to find the radius, and we can have a little bit of a shortcut here. We know that if we square the x and we square the y with the Pythagorean theorem, we're going to get the radius squared. The x value plus the y value, both of them squared, equals the radius squared. And if we go back 1 second to this previous example, that's exactly what we did here. We squared the x and we squared the y, and that equaled our radius squared. Now, if I'm trying to find out what my radius is, I just have to take the square root of both sides. So we could say the radius is just the square root of x squared plus y squared. Now, the nice thing about using this definition and these definitions on this slide is that you can find the values of all these trig functions without drawing the picture. Now, that doesn't mean you can't draw the picture. A picture is always a really great place to start. This just gives you another option. Let's look at one more example for today. And we have our point 1, negative 3. It's the terminal side of theta. And we want to find the values of the 6 trig functions once again. So I'm going to show 2 ways. Let's first just find the radius using that last formula I gave you. Now remember, we said radius is going to be the square root of the x value squared plus the y value squared. So that means we'd have the square root of 1 plus 9, which equals the square root of 10. Now, if instead you choose to use the triangle, you'd want to plot the point 1, negative 3, and it's going to be down here in quadrant 4. And so you'll draw your radius in, and then you'll bring your right triangle up to the x-axis there. So now your side lengths would be x is 1, y is negative 3, And we need to find the radius. And if you go through the Pythagorean theorem, 1 squared plus negative 3 squared equals the c squared, or radius squared. You'll see in the end you get the same answer as I did above. And so you can see it's two ways to get to the same answer, and you can decide whichever way you prefer. Now, we'll still get the square root of 10 as our c value when we take the square root, and so our hypotenuse there, the triangle, is the square root of 10. And remember, the theta is inside there. That's going to be the reference angle we're using. Even though our theta really is the angle that goes all the way around and ends there, we're going to use that little inside triangle to get the answer. Now that you have the triangle and the radius above, you can either use the definitions on the previous slide, or you could use the triangle to find all of your trig functions. So the sine of theta. Now in this case, I'm just going to use the definition on the previous slide, which says sine is y value divided by radius. So we're just going to say negative 3 over the square root of 10. If you used opposite over hypotenuse in the picture, you'll get the same answer. And when you rationalize, negative 3 root 10 over 10. I'm actually going to let you pause your video, and I'm going to let you find all the rest of these. We'll go over them tomorrow in class, but I do want you to answer the tangent and the cotangent in your Google form. So you're going to find all the other 5 answers, but I just want you to put tangent and cotangent into the Google form. When you're done with that, the next slide has the multiple choice question for the day, and that's the end of our video. So here's your multiple choice question. You're given the point 912. I'm just looking for the cosine of theta. And that's where we'll end for today.